Hey everyone, Andrew Stormer here, and welcome back to another computer tutorial. And today we're talking microphones. Now, this isn't exactly a computer tutorial because it's microphones, but microphones do have to do with computers. And if you want to do any type of filming or sound making, or you just want a YouTube recording setup or anything like that, you're gonna need a mic. So it kind of fits in some, and there's a lot of specs to go over. So I'll try to get through them as fast as I can with as much sense as possible. So starting off here, we have a whiteboard with form factor. So I'm just gonna go through this super quick, but we have boundary, which you'll see an example in a minute. But it's just a little one-sided mic. It's like this big, kind of. Sometimes you see them like hanging down from a studio, whatever, in the sound recording room, and it only does a certain area aimed straight at you or something. Or it could be like a tabletop that's aimed a certain way. You'll see it in a minute. There's desktop, which is kind of like your old radio style microphone. You have a gooseneck, which is something that you'd see like in court or in a meeting or something like that. And these can be like moved around and stuff. Handheld, that's your typical mic that you see at every concert, every speech event, whatever. You have head worn, so you can see there's little facer dude. And this could either be like a headset or just a little wire that comes in right by your mouth. There's a lavalier, which these people usually call lav mics for short, and they usually clip onto a shirt or your tie or something, and a lot of times these are wireless, or you record it to like a phone or something. And then you have shotgun, which is like this, which I actually have one right here. Hi, see, this goes on my camera, and I'll get more to that in a minute. We have side addressed, which this one actually has two sides, where these ones are all just one way, but this one, it can be directed from either side of it. And these are usually your typical mics for YouTube or podcasts or whatever. And then polar pattern. We have bidirectional, and this is the polar pattern here. This is how it actually looks, like the angles, how it picks up from the mic. So in the center is the mic, and then like the angles are there with the area that it does pick up of sound. So this one, it's up and down, not up and down, but like the front of the mic and the back of the mic. You have cardioid, which sometimes we call cardio, and because it looks like a heart, and it just gets the front. And how polar pattern is gotten is if I whip out my calculator here, and we are in polar mode. You can kind of see that right there. And then if we go into graphing, here's just an equation here, and we're gonna graph it, and that's what a cardio graph looks like. That's what a polar pattern looks like. And it's because this is how you get a polar pattern. Polar patterns are, all they are is just a math equation, which is the mic sensitivity of direction of where it picks up sound. And then we have half, which you can see it kind of has that heart shape a tiny bit down here, but it has that little sticking up thing right here. This one is actually one of these types, which again, you'll see in a second. And then you have hypercardioid. So it has a tiny bit in the back, but mostly in the front. And then actually down here, I'll jump here, the supercardioid. It's just a lesser version of the hyper. So it looks like it's exactly the same when it's actually just less. Shut up, phone. And we have subcardioid, which isn't a circle like omnidirectional. It actually, at this point, goes in less, so you pick up less sound near the back, but it's still kind of an all-around. And omnidirectional is just equal all around. And then it also does the top of the mic. it's not just all around the sides, but also the top. And then you have low bar, but this is also a shotgun like this. And this here, you can see it's wherever the end is, wherever it's pointing is where it picks up. All the stuff on the side, it doesn't really pick up. And then I had to cram down here. There's stereo, which is kind of like a bidirectional, but a bidirectional is the front and the back, when a stereo is actually the left and right. It's the two sides, and it does hit a little bit on the front and back, but not really. And then you have toroid, which you'll see a better diagram here, but it's like an omnidirectional, except that it's limited to an area. So instead of being like all around and on top, it doesn't do the top and only does like this area in here. It's really weird, and I'll show you right now with all these different papers of examples. They're all from Shure, because Shure just does a really good job on including like the polar patterns and the frequencies. So you can see that's a cardioid right there. This is what I was talking about with the toroids, is that it's an omnidirectional, so it's all around, but it's flat on a surface and it only encompasses a small area and it doesn't get that much above. You can see this mic also has some other different options there. And this is what I was talking about earlier with the one-sided thing. So sometimes you see these like hanging down and people grab them or whatever. They can also be like a desk thing right there. So you can see how it can just be on a desk and see how it only gets a 60-degree angle aimed a certain way. So it's kind of weird and stuff, but it's an option there. And this one actually has a really weird frequency range here, and some mics are switchable, like this one. This one can be switched into all different types of polar patterns and frequencies. And you see the frequencies actually change with what polar pattern you're going for. And I'll go over frequency response right now too. This is the area that a microphone picks up. I talked about this in the speaker video last week. If you didn't see it, go check it out. Link up there. And you can see here, it's not all flat. It accentuates these frequencies more. Sometimes you want it just flat when you are trying to just encompass everything as best as possible. But sometimes you do want not 20/20, you just want a small area, and sometimes you do want parts being higher and more produced than other frequencies. That kind of stuff can come in for sound-specific microphones. Some of these mics are tailored to bring out certain frequencies to make a better sound for its specific job. An application for that is that you could have a mic that is made to pick up a drum sound, and a mic that's meant to pick up a voice, and a mic that's meant to pick up a guitar. And each one does it differently, and if you use the drum mic to pick up the guitar, it wouldn't sound good. So you can get some more specifics, but that's like super advanced, like bands kind of stuff. And you also see here, you have this version here, but you also have this roll-off symbol. And if you look on my mic here, you can actually see it up here. The straight line there is just on, but that one right there is the roll-off. That is also called a high-pass filter, and what it does is it cuts off the low frequencies. So down here where the low frequencies are, it rolls off and starts cutting them out. So if you're only focusing on like a human voice or certain noises over here, or you're trying to get rid of like deeper bassy noise or whatever, trying to make it quieter, but you want everything else the same, there's some applications for that. You can just slide it over to the roll-off and then it cuts them out. Now for type. So there's a few different types. There's ribbon, which works like this, where you have a plate in between two magnets, and these have a pretty low output, meaning they don't have a lot of gain, meaning they are better at picking up loud sounds, and they're better at not blowing out loud sounds. Array means there's a bunch of different diaphragms, which some of these mics do have diaphragms, some of them don't. Like the Ribbon doesn't have a diaphragm to pick up the sound. There's dynamic, which this is kind of like almost an inverse speaker. A speaker works similar to this, where you have a diaphragm here and the sound pushes the diaphragm with wires in a coil on it against a magnet, so this piece here moves up and down on the magnet, and that makes the input for the sound. This is also called a moving coil type of microphone. And dynamic microphones, they don't take phantom power, which I'll explain in a minute. Then there's condenser, which has a diaphragm like this, and the diaphragm on a condenser means the diaphragm moves around. The entire thing doesn't get pushed around like a coil one, but it moves in, like the middle part moves in. Condenser mics, they require phantom power, and they are better at picking up sounds than a dynamic because they can pick up smaller sounds and they have a higher frequency range. And then there's called Electret condensers, which is a condenser mic, but the electricity is like frozen kind of in it, so it doesn't take phantom power. I don't really see why you'd need an electric condenser because you're still gonna have a cable connected to it for the input of the sound. And if you have a cable in it, why can't it send the power? I don't know. So out of all of them, I think the most widely used and the one that you'll probably want is a condenser, and I'll get into why in a second. Phantom power, what that is all it does is it sends power to the mic externally, when mics that don't need phantom power either have the power in it or just don't need electricity at all. There's small and there's large diaphragms. Small diaphragm picks up sound better, but it has a low SNR, which I explained in the speaker video last week and the sound card video. Basically, the lower the worse, because you have more white noise, which you really don't want. And small diaphragms are slightly better for high frequencies, but large diaphragms are better for lower frequencies and makes the voice sound better. And it has a higher SNR, meaning there's less white noise in the background, or at least that you can hear. Even though small says it can reproduce sounds more accurately and better, when you're doing YouTube or recording a voice or something, you want that rich sound in people's voice. And that's where I would actually recommend a large diaphragm and then condenser microphone. And for polar pattern, I'd recommend either a shotgun or a cardioid. Unless you're doing a podcast, you might want like a bidirectional or an omnidirectional if you have a lot of people. That's my recommendations for if you're wanting to start up YouTube and get a mic for yourself or anything of the sort. And if you're doing any kind of filmmaking, I'd get a shotgun mic like this that you can just slap on your camera, or a mic kind of like this, but it's not pointy, it's more of a circular. It picks up more of around you, so if you have people in front and behind the camera, that it can pick up better. And one thing you might have noticed is on this mic here, you can see there's the -10, 0, and +20. Those are just, it boosts the output of the sound, so if you need the sound to come out a little bit louder, you can slide it over to +20. If you need it a lot quieter, you can just do -10. It's not really a big deal, and not a ton of mics come with that. It's kind of a way of gain on a mic like this, and gain is the sensitivity to a mic. And like a Yeti or other mics, they have like a knob or something on it to change the gain of it. Like I said, that's the sensitivity, meaning that a higher gain, meaning it can pick up quieter sounds, when a low gain means it's less sensitive, meaning it doesn't pick up the quieter sounds, but is better for loud sounds because it's not going to blow them out. Couple small things that you might forget or whatever. There's wireless mics, Bluetooth mics, there's wired mics. Some mics, they have a built-in headphone amp, some have a push to talk button, some you can push to mute the mic. They have different connectors, so some have USB, some have XLR, and if you have an XLR and you're trying to record to a computer, you might need a audio interface like this. This is the Focusrite Scarlett, and this has 2 XLR ports right here, and you can see you can actually control the gain on this one from itself. First, it's external, and second, it's not as much of an output, it's more for input. Some mics also have built-in stands, and then there's tripods. There's also, instead of a tripod legs that can fold up, it's just a round bottom. There's boom poles, which is just a pole with a mic kind of like this on the end of it. And sometimes in the movies you see people standing way back holding this pole that goes way out and a mic comes down. And some of them, they can be like put on a stand that either like this level that it's aiming up, and some of them, they can be on a stand that's still overhead and coming down so someone doesn't have to hold it. There's a bunch of different boom pole options like that. Then there's mic arms, and one like this one, this is made by Rode. This actually like clamps onto the side of a desk, and then this arm can kind of like be moved around with springs and stuff, and then you attach the mic onto the end of that. Or you can put a shock mount on the end of it. So it attaches here, and what this is you have this outer ring, which is connected straight to it, and then you have this inner ring, which the mic sits in here, and this inner ring is connected by rubber bands to the outer ring, so it can kind of just shift around, meaning that if there's any sort of shock on the outside, what a shocker, that it's not going to send the sound into the mic. If you're banging on a keyboard in a game and your mic is standing straight on your desk, you're going to hear that annoying tapping. But with a shock mount, that outer ring is going to have that vibration go through it, but hardly any of it is going to go through those bands. So then the mic doesn't pick it up. And that's really nice. And also they do it on these mics for like a camera, a DSLR. And this one's a different type of shock mount, but you can see that you have these rubber pieces, so then the mic can just shift around. So any sort of like bouncing or little shakes or anything, the mic isn't actually gonna pick up those vibrations, at least not that much, from the camera. Like if the camera gets hit or something, you just get nicer audio with those. There's also pop filters. There's pop filters like this that go in front of the mic, and pop filters, they take out the pops, the where you can really hear it sometimes that the mic blows out those pops when someone's speaking, like at an event or something, when they don't have a pop filter. And I really wish they would use one. And this isn't gonna work for everyone's setup because this one here is a desk mount. You can get ones that mount to like your stand or whatever right next to your mic. And this one is made out of a fabric, but some of them have like a hard weave to them. And then there's ones like these that go over the entire mic, so it's kind of an all-around one. And then there's ones like these, which are a half circle kind of thing. You can see right here how it goes onto a mic like that. That one doesn't take a stand, you just slip it onto the top of the mic. There's all those different options there. And then there's a thing called a windscreen. And some pop filters and windscreens are like built in together, but there is a little difference between the two. The pop filter is meant for the pops, when the windscreen is made for more of taking out wind noise, like if you're shooting outside. Now, this mic is actually looks like this, and you can just barely see, like the diaphragm is right behind those 5 to 6 circles way down there. It's just right behind there. And if you just left it like this, This would be raw audio here. This is kind of a windscreen pop filter here for it. And then there's this here, which is another windscreen that goes over the top of that. And this one specifically is called a dead cat, which is kind of funny, but that cuts out even more wind noise. And you really don't want wind noise when you're recording audio outside. I know this video's gone on for a long time and there's been a ton to take in, but microphones, they do have a lot to them, and it's all dependent on what you need it for. If you're recording a voice, or if you're recording just sounds or a specific instrument, and are you shooting outside with a camera like you'd want something like this, or if you're shooting inside with a studio and recording games or something where you might want an arm, a shock mount, a pop filter, and a condenser mic with probably like a large diaphragm. There's all these different options out there, and it's what you need. That's gonna do it for this one, so thank you all so much for watching, and I'll see you next time.